Mr. Harris here, and welcome to a new video. In this video, we're going to wrap up this part of calculation of moles and, of course, to find the number of particles. So here, calculate the number of carbon atoms in 17.6 grams of CH3, CH2, CH3. What's that? Now, this is propane, and you're asked to find, again, the number of carbon atoms. In this case, carbon atoms, but in other words, they're asking you to find the number of particles. That means we will be using our first and second equation. So here, let's find the number of moles of our propane, the number of moles of CH3, CH2, CH3. The equation is number of moles is mass equal to the mass over molar mass. The mass is provided to us, it's 17.6, and the molar mass is the addition of the relative atomic masses. I've told you many times. So carbon here, how many carbon atoms do I have? 1, 2, and 3. So the relative atomic mass of carbon is 12, times it by 3, and plus the relative atomic mass of hydrogen. Now, how many hydrogen atoms are there? There are 3 plus 2. So 3 here, 2 here, and another 3 there. So 5 plus 3, that is 8. So relative atomic mass times by 8. And then when you do the calculation, you should get 17.6 divided by, it's 44. 17.6 divided by 44, you should get this is 0.4 mole. Okay, now afterwards, as I said in the previous video, you do not start immediately using the second equation. You will need to have the number of carbon atoms first, the number of moles of carbon atoms, I should say. So what is the number of moles of carbon atoms? Number of moles of carbon atoms. Now, as I said, you'll take the number of moles of the entire compound and times it by whatever number of carbon atoms there are. So we found it already, actually. There are 3 of them, and you can see it up here again, 1, 2, 3. So times it by 3. 0.4 times 3, that is 1.2. So 1.2 mole. Now you could use your second equation and learn. So I'm going to just directly use it because we've done it so many times in the previous video. So 1.2 would be equal to the number of carbon atoms, that's what we're supposed to find, divided by Avogadro's constant. So 6.02 times 10 power 23. Therefore, the number of carbon atoms, now I'm just going to scroll down here, number of carbon atoms would be equal to 1.2 times by our Avogadro's number. And you should get the answer for this. So I'm just typing on my calculator. You should get this is 7.22 times 10 power 23. Just leave it to 3 significant figures. So there you go. That's it. And then here, part B. This time, notice it's asking you the same question as earlier, but the difference is now they're asking you to find the number of hydrogen atoms. So we're going to use the same technique. We already found the number of moles of propane here, which is 0.4. So I'm just going to copy that down here. The number of moles of propane. And I prefer you to write it every single time so that the marker could give you 1 mark. So you give them more opportunities to give you a mark. So, and then now we need to find the number of moles of carbon atoms, obviously. So number of moles, not carbon atoms, but hydrogen atoms of hydrogen atoms. This time, how many hydrogen atoms are there? There are, we already found it up top here. Remember when we were finding for the relative atomic mass, there are 8. So here, 3 plus 2 plus 3, that's 8, times 8. So 0.4 times 8, that is 3.2 mole. And then use our second equation again. So second equation was the number of moles of hydrogen atoms. It will be equal to the number of particles, which here is hydrogen atoms. divided by L, or 6.02 times 10 to the power 23. So every time you don't really need to write this, you can immediately just write the final answer like here. Just write the number of hydrogen atoms is equal to 3.2 times 6.02 times 23. And then find the answer for this, 3.2 times 6.02 times 10 to the power 23. This here now, be careful, it is three significant figures. You'll get 1.93 times 10 to the power 24. Oh, here, the power, you can see it's become to the power 24. Okay, and that's it. That is how you use the two equations. Now to summarize everything, we're going to use all of this in this question here. Now see, there are 50 grams of aluminum nitrate. This is aluminum nitrate. Calculate, and you have a bunch of questions. So let's do that. Number of moles of cations. Now what are cations again? Cations are positive ions. So here, which one is the positive ion? We have aluminum nitrate. So obviously, aluminum, we know it is in group 3. So it is Al3 plus. And also, you can figure it out by, remember how do we get the chemical formula for this? It's like we're going backwards. So this is how the number came down here. Remember that? So originally, this number on aluminum was coming from this orange one here, so which is 3 plus. And the number on nitrate, we know it's negative. But technically, you should already know this. Aluminum is in group 3. All group 3 elements are having a 3 plus charge. Nitrate ion, in book 1b, I told you that it's better you memorize it. But here, but the question now is, how many positive ions are there? How many positive ions? That is where you will need to look at the chemical formula. Here, what does it actually mean by this 3 that you see for nitrate? This means that there are 3 nitrate ions. So there are 3 nitrate ions. So maybe I'll write it like this. There's 1, 2, 3. Okay? And what does it mean by, there's no number here, but what does that mean? That means there's just one aluminum ion. Okay? So what is the number of moles of cations? So simple enough. To do this question, first, what I suggest you to do is to, maybe on the side here, let's do it on the side here. Can you tell me what's the number of moles of this entire compound? Remember, whenever we're going to find the number of atoms, number of particles, I prefer you to first find the number of moles of the entire compound. So we're going to do that first. So the number of moles of AlNO3, which will be equal to the mass over molar mass, right? So which is 50 over, 50 is the mass, over the molar mass. Aluminium is 27, the relative atomic mass, plus, now nitrogen is 14, the relative atomic mass is 14. But how many of them are there? How many of them are there? There are 3 of them, right? So don't forget, you need to times it by 3. Okay, plus, I'll close the bracket, plus how many oxygen atoms are there? 3 inside the bracket and 3 outside. Remember, I said this is a times plus 16 times 9. Okay, plus 16 times 9. So here, I'm going to rub this part out. You should get, the answer for this is 50 over 27 plus 14 times 3 plus 16 times 9. This is 213. Now this is equal to 50 over 213. You should get the answer is 0.235 mole. Okay? Or there's another way to do the molar mass here. Now I did this technique, but of course you can do another technique. Well, I'll do it down here. You could do it 50 over, now instead of, for the NO3, instead of doing it like the way I did, you could do it another way, is you can first write down all the relative atomic mass, those that are inside the bracket. So nitrogen is 14, plus how many oxygen atoms are there? There's 3 of them, so 16 times 3. And then this whole inside the bracket, you can times it by 3. So this is another way for you to calculate it. You're going to get the same answer as the one on the top. Okay, now let's do our question. Number of moles of cations. Now, how many cations do we have? Originally, as I said, I have 1 aluminum ion and there were 3 nitrate ions. So here, I'm going to go ahead to find the number of moles of cations. That means they're asking me to find the number of moles of aluminum ions, and I only have 1 of them. So I'm going to take my compound, the number of moles of the whole compound, and times it by 1. And that will be my answer. So it's still 0.235 mole. Okay, so it's the same thing that you were doing here. Remember, we were finding the number of moles of hydrogen atoms. So now they're just replacing the word particles, which originally we found was atoms here. Now we've just replaced the word of particles with the word of cations. And we're going to do the same thing with the word of anions here. So the original compound was 0.235. Now anions here, I'm going to use the same color. There are 3 of them here, right? So times it by 3. And then you take out your calculator and times it by 3. You should get this is 0.705 mole. Okay. Now you're supposed to find the number of cations. In other words, you're finding the number of particles. So the number of particles, it's simple. So it's now you're literally doing this step here. So here the number of particles is equal to the number of moles times by L. So I'm not going to copy it anymore. I'm just going to directly write it. So here the number of particles, you found it. The number of moles of particles, you found it here in part A. This is 0.235. 0.235, and then you times it by Avogadro's constant, which is 6.02 times 10 power 23. And then you find the answer times 10 power 23. You should get this is 1.41 times 10 to the power 23. Now they're asking you the same thing for part D. They're asking you to find the number of anions. Now you found the number of anions. Sorry, you found the number of moles of anions, which was 0.705. So just do the same thing. And then times it by, to find the number of particles, you need to times it by Avogadro's constant. So again, use your calculator. 0.705 times Avogadro's constant. You should get this at 4.24 times 10 to our 23. There you have it. It's just that simple. So don't worry about it much. It's just using, all of these questions are just going back and forth with asking us about the equation. Now part E and F, they're asking you the number of nitrogen atoms and the number of oxygen atoms. So again, to find the number of nitrogen atoms, you're going to go back to the original, question and see how many nitrogen atoms and oxygen atoms are there. And we're going to go back and use the number of moles of our compound. Remember, we're always going to refer to this and do our math or do our calculations here. So here, the number of moles of, the number of nitrogen atoms. So first I'll need to find the number of moles of nitrogen atoms. Number of moles of nitrogen atoms, and actually we have three nitrogen atoms there. So simple. I'm gonna take my, it's using the highlighter. I'm gonna take my number of moles of the entire compound and times it by the number of nitrogen atoms I have, which is 3. It's the same thing you did here, remember? To find the number of moles of hydrogen atoms, what did I have to do? I had to find the number of moles of the entire compound and times it by the number of hydrogen atoms I had so that I could get the number of moles of hydrogen atoms. So here, what I'm doing right now is I'm trying to find the number of moles of nitrogen atoms. So 0.23 times by 3, which is equal to 0.705. Okay, this is the number of moles of nitrogen atoms. And then to find the number of nitrogen atoms, I'm just going to use Avogadro's constant again. So times by 6.02 times 10 power 23. Then after, because I've done it so many times, I'm ready of the habit of I can just apply the equation. So here the answer for this would be, you can see it's similar to the one that you found before, 4.24 times 10 to the power 23. And then finally for F, I'm going to do the same thing. The number of moles of oxygen atoms, I'm going to find that first. So perhaps I'll write here for you. This was the number of moles of nitrogen atoms. And that's how I got it. So here, the number of oxygen atoms. First, I'm going to find the number of moles of oxygen atoms, which was 0.235 of the entire compound, and times it by the number of oxygen atoms there are in the question. So here, there are 3 inside, and then the number outside, you need to times it by 3. So 3 times 3, 3 times 3, that is 9. I'm already mixing up my English. So times 9. And then take out your calculator, do it. This is 2.115 moles. And finally, to find the number of oxygen atoms, just take this number and times it by Avogadro's constant. And you should get the answer here is 1.27 times 10 to the power 24. And there you have it. You have found all of them now. So I'll repeat what this question I was talking about. This included all of the 3 past videos that you have learned. So first of, whenever you see any question and you're stuck, you're like, sir, I have no idea, how am I supposed to do it? So I suggest you always find the number of moles of the entire compound. And then you can start playing with the second equation. Like here, they're asking you to find the number of moles of cations. That means Al3 plus. And then here, this is NO3 minus. But this is where some of you might get confused. You're like, sir, now all of a sudden they're asking us to find the atoms. Again, it's the same thing like before. You find the number of moles of that particular particle that they're asking you in the question. Like here, oxygen atoms, nitrogen atoms, and then you times it by the number of atoms there are in the compound, and finally you times it by Avogadro's constant, and there you go, you find the answer. Okay, and to give you a hint, always the number of atoms, you'll see that the answer would always be like 10 times 10 to the power 23. So this is a hint. To find the number of atoms, they would always be in this sort of number. If you find that the number of atoms is just like a very tiny number, when I mean a tiny number like 24, 25, that's not enough. It should be times 10 power 23, times 10 power 22, times 10 power 24. And that's a hint for you. Okay, so I'll end here, and I'll see you in the next video then. Bye.